We're now going to start working on a systematic way to name alkanes, but this system is going to be extended to other functional groups as you progress through this course and Organic 2. This system is referred to as the IUPAC system. IUPAC stands for the International Union of Pure and Applied Chemistry. And in a simplified sense, this is just kind of a cohort of chemists from across the world that get together and decide on the best systems that are consistent for things like nomenclature, classifications, releasing updated versions of the periodic table, and things like that. The general pattern for naming an organic molecule is pretty consistent. We name the substituents, followed by the parent. But first, let's define what these two things are. So the parent is going to be your main chain, which is the longest continuous chain in the molecule. The substituents are the things attached to the parent. So this can be an atom or group of atoms. The best way to learn how to name molecules is by doing an example. So we're going to go through an example and I'm going to list the rules for you to do this. In some cases, the rules will have more information than we need for this particular example, but when you work other examples, you can come back and apply some of these things. So the first thing is to find the longest continuous carbon chain in the molecule. Sometimes that takes a little bit of trial and error, but basically you want to find one endpoint and trace the longest chain you can without picking up your pencil. So in this case, I can capture 2 carbons here to here, go to here, and then if I go up, I only grab 2 more carbons, but if I go down, I can grab 3 more carbons. So that's my longest chain, that's the parent. You know how to name, or you know the names of the straight chain alkanes at this point, and this one has 1, 2, 3, 4, 5, 6, 7 carbons, so you should know that that is heptane. That's your parent. A sub-rule here that doesn't apply in this example, if you do have 2 chains that you find in the molecule that are equal in length, pick the one that has more substituents attached. So in this case, this parent chain has 1, 2 substituents attached. So if you run into that kind of tie, that's how you break the tie. The next thing we do is number the atoms in the parent and begin at the end nearest the first substituent. So if we start right here, 1, 2, 3, we have our first substituent at 3. If you start down here, 1, 2, 3, 4, you don't have your first substituent until carbon 4. So starting up here is the better option. So let's number this chain. Here's our 7 carbon atoms. Now we need to find our substituents and name them. So we have a substituent at carbon 3, and we have another substituent at carbon 4. So let's see what those are and how we name them. Let's start with carbon 3. This group at carbon 3 is a carbon with 3 hydrogen attached, and those are implied hydrogen. If you want to write out that group, you can write that it is a CH3 group on that carbon. So at carbon 3, we have a CH3. Now, if we think about what this would be if it were one of the alkanes, the corresponding 1 carbon alkane is CH4. And we know that that is methane. So the substituent that corresponds to this, if we just kind of think backwards, what we've basically done is we've lost a hydrogen. And the way we represent that in the name is you change the ending. So CH4 is methane. When we lose that hydrogen and we get this substituent group, we change the ANE to YL, and this is called a methyl group. So then on the parent, what we say is that we have a 3-methyl. Then at carbon 4, we have a CH2 CH3 group. So we have the attachment to the parent, CH2 CH3. What does that correspond to in terms of our alkanes? If we add one more carbon, we get the 2-carbon chain, to CH3 bonded to CH3. We know that as ethane. So we're going to follow the same thing we did above. If you lose a hydrogen, we change the ANE to YL. So instead of ethane, this is ethyl. So now the substituent at 4 is called a 4-ethyl group. We've taken care of rule 3. We've identified the substituents, we've numbered them, and named them. So now we have everything we need. We just need to put the name together. So now what we're going to do with this is we're going to write the name as a single word. We list our substituents alphabetically and follow it by the parent name. A couple guidelines on putting a name together. If you're separating a number and a word, we use hyphens. So that's what we did, like between the 4 and the E in ethyl, or the 3 and M in methyl, we separated those by hyphens. If you're writing 2 numbers, we use commas to separate those, and we'll see that in some other examples. There should be no spaces. And if we have multiples of the same substituent, we use the di, tri, or tetra prefixes. So for example, if you had 2 methyl groups in the molecule, instead of writing that twice, you would just say dimethyl. So applying this to our example here, we'll start with our substituents, and we have to write those alphabetically by the E in ethyl, the M in methyl. So E comes first, so we start the name 4-ethyl. Then we need 3-methyl. We separate the end, or the L in ethyl, and the 3 in methyl by a hyphen. So we separate all numbers and letters by hyphens like that. So those are our substituents. Then we just finish the name with the parent, which is heptane. There's no spaces in this name. And we do not put a hyphen here because those are just 2 letters. You only hyphenate between numbers and words.